I'll be asking questions, and if you guys could be ready on the chat room to sort of answer some of these questions, that way I can work on. I can tailor the presentation a little bit more to your guys' needs. Okay, so like Cyan said, I'm Christopher Dossman, Google Developer Expert, and today I'm going to be talking to you about sort of AI products and like building a proper AI product. There's lots of blog posts and talks about the technical challenges with developing a classifier or some other ML system like anomaly detection, but there's very little on how do you decide which products are really worth it, and then of the products, how do you set it up so that this ML product will get the highest value that it could possibly get. So I'm going to be using this presentation I did recently at a Google Developer Group event in Kyrgyzstan. Without further ado, let's go ahead and start. Besides being the founder of EducateAI, I also run the AI team at a mobile gaming company. So some of the examples I'll be going over are for specifically that company. Great. So just a little outline of what we're going to do. We're going to do a little bit of a survey in the beginning, so I'm going to need you to answer back the questions. We're going to go into why machine learning projects are difficult and why they're sort of a lot different than normal software engineering projects. We're going to go over some stories to highlight what goes wrong when you don't think about these things, or you don't think about AI projects. And then we're going to go over some of the best practices that are known now. And I'll show you some worksheets and other documentation that you can go through in order to learn a lot more about the sort of optimized AI product design. So really quick, AI is everywhere. Maybe 4 years ago, you could say that AI will be everywhere. Now I feel like you could say AI really is everywhere. It's in almost every single product you use to some degree. It helps tailor the experiences of the users on that product, and that's very powerful, because when you're building a product for 1 billion people or 100 million people or even just 1 million people, personalization and recommendation and all of these things are very important to providing each user exactly the experience that is best suited for them and that will give them the best value. So who here has worked on AI products before? Can we get a little bit of a, I guess, maybe not show your hands, but maybe you could just, okay, there we go. GM, I got a raised hand. Anyone else work on an AI product before? AI project? Yes. Okay, nice. We got four people worked on AI products before. Could I get one person, 5 people, can I get one person to open up their mic and just describe what they have done? Maybe we can get maybe Cyan. You want to go ahead? I know you have permission to use your mic.
Yeah.
Describe your project for us.
Okay, so my project is I'm still currently working on it. It's 80% complete, but my project is basically about shoplifter analysis and detection. So whenever people try to shoplift, basically we have made a camera, we take the feed from webcam, and whenever using pose motion, when people try to steal or do some kind of shoplifting, we detect that. And also we have emotion detection, so emotion recognition and sentiment analysis of people when depending on how happy they are, or if they are not satisfied with the store, we gave an average rating to the whole store that, okay, your customers are happy or your customers are not happy, you need to change the environment. So that's the project I'm currently working on. It's 80% complete.
Well, that's a very interesting project, and that I think we're going to use that as an example going forward. All right, and for
Okay.
all the other people who raised their hand, I do want to hear about your project. We'll leave some time at the end of the presentation for you to describe your project, and maybe we can chat more about it, and I can help you guys out more individually if that's something that you're interested in. Okay, so let's continue. Let's see how many people are in the chat right now. How many participants do we have?
It's about 16, no, 17.
Okay, so about 5, 6, 7 out of 17. That's pretty good. So, okay, a lot of you have worked on AI projects before. And for those that haven't, I wouldn't be surprised if you do end up working on a ML system. Maybe not you developing it yourself, but working with ML APIs in order to provide better service to your customers and your users. So let's share some failures. I'll go ahead and share my failures. And I think this is very interesting because it actually has to do with one of your projects, the emotion recognition project for your thing. So it's one of my failures. Or, you know, I can use another example, but we'll go through the emotion recognition. So I spent a year developing an emotion recognition service that worked on face and voice, maybe around 2 years ago, 3 years ago at this point. And the problem was with this is that we were sort of at that time AI was very new. It was very easy for us to get a lot of good investor feedback. So we built this technology and we spent a lot of time trying to make it work really well. But the problem was we just built it because we could. We didn't really understand our users' needs or what they actually wanted from emotion recognition. And so we never really found a customer because we didn't take into account any of the issues that they were facing, the users. And I think that's a very easy thing for ML projects to lose sight of. It's very exciting. The technology is really cool to work with, and the process can be a lot of fun if you're into machine learning. So you sort of lose sight of what really ends up mattering in anything you do. It's, you know, what problems are you solving, and is the problem that you're solving a problem for someone, enough of a problem for someone that they actually care. And I think that's at the heart of many AI failures, is just not understanding the user's needs. So yeah, I'm sure you're all familiar with that. Even if we have the best technology, this code is supposed to represent advanced technology. Even if we have the most amazing emotion recognition or shoplifting detection system, if we're not constantly in contact with our end users and with the people who will end up adopting the system, we're gonna face some pretty big issues down the line. And you know, this is evident in some of these examples I'm about to share with you. So I'm not sure how many of you are familiar with IBM Watson. It was really big. They beat Jeopardy before, and they got very popular, and everyone was talking about how Watson was going to change the world. Well, Watson started being used in cancer treatments as a tool, a diagnostic tool for doctors. And because the technical team behind Watson was to make a long story short, Watson ended up being a complete failure, and doctors were quoted as saying that it was less useful than not having anything at all. So it was counterproductive. And to boil it down, it was basically the engineering team was not in constant contact with the end users, the doctors. They were in contact with the salespeople. And so what ended up happening was just they were putting all these technical resources solving issues that no one actually had. They were solving fake issues. They were solving made up issues. And if they had focused more on the end user, the doctor, and building up a good feedback cycle with that end user, they would have probably ended up doing well. Now I think there isn't too much investment into Watson for that. How many are you familiar with the Tay tweets, a Twitter bot that Microsoft released? I think at this point, maybe a year or some ago. Anyone familiar with this? Well, Microsoft. The problem with this was not that Microsoft and the engineers behind this weren't understanding the end user needs for this. What they failed to understand was the behavior of the users in interacting with their system. So this is another example of a machine learning system going wrong, but because the user wasn't necessarily using the system in the way that the engineers expected. Yeah, racist Twitter bot by Microsoft. It didn't start off racist. It started off very nice. You can see here. Oh, can I just say that I'm stoked to meet you? Humans are super cool. And then over the course of one day, after interacting with the Twitter community and getting feedback from the Twitter community, the Twitter community managed to turn Tay tweets into a racist Twitter bot. And of course, the last example is, again, this is an example not of misunderstanding user needs or of misunderstanding how the user interacts with your system. This one was just this was an engineering fault for those who are not familiar with this photo. This is a photo of an Uber self-driving car that ended up killing a person on the street. Ran over a person in the street that was walking their bike across the street. It was a very sad story. And this highlights an engineering error where they didn't understand the risks associated with their ML system. This was a case where at the end of the day, when they did the investigation, they found out that Uber just, the car didn't stop, not because it didn't see the person. It saw the person in the road, and it saw that it was in the way. It didn't stop because an engineer had hard-coded a rule into the self-driving car that basically said that there's no such thing as a person in the road. That doesn't exist. In my mind, I'm not sure why anyone would take that specific path to fixing an issue, but it's clear that they were having trouble with identifying people in the road suddenly, perhaps, and that was causing issues with sudden braking in their cars. And instead of thinking of the downstream consequences of hard coding it so that people could never, in the mind of the machine, never be in the road, that was a failure of imagination on the part of the engineer and to the consequences. So it's easy to build software systems that are robust and that can fail gracefully and that take into account the user's needs, because software development has existed for a long time, and the best practices have really proliferated throughout the industry. So there are ways of doing things that are just from 40 years of experience of doing those things. Take, for example, agile software development, or using Git for version control, or the microservices architecture in order to build highly scalable systems. Best practices for software development exist, but for AI, they're not really there. And you can see that in the errors that we just error examples that we just went through. And this is bad because AI systems and software engineering systems are completely different. Well, not completely different, but at the end of the day, they're very different beasts. So software engineering is discrete systems, right? So 1 + 1 is always going to equal 2. So it's very easy to know or to guess what state a software system is going to be, and it's very easy to modulate how a user interacts with that system, because the user can't do anything weird. Like, even if the user tries many different things, the system is going to always act like the system would. AI systems are probabilistic, so when you say 1 + 1, you can't always say it equals 2 to AI systems. Based on the data you've trained it with, the data set you've trained it with, based on the variety of that data and all of these different external factors. Sometimes when you give an AI system 1 + 1, it will give you 2 most of the time, but it's completely possible that it could give you 1,000 or -1,000. So this is something that is not really accounted for, and that we're going to have to build up experience for. And this is where we get into the meat of the presentation. And it's basically a guidebook developed by Google. So it's called the People Plus AI Guidebook. And it goes into all the ways, all of the things that you have to think about when you are developing AI products. And these are very important to keep in your mind. And so again, we have we'll go through the different sections, and then we'll in this presentation I'll dive deep into some of these sections. But it covers user needs, it covers data collection and evaluation, explainability and trust, mental models, feedback control, and errors and graceful failures. So if you're able to take into account all of these things and go through the guidebook for each one of your projects, AI projects, I can't guarantee that you're not gonna have an issue, or you're not gonna fail like the examples that we discussed earlier. But what I can promise you is that 90% of your problems will just disappear, because this covers most of the major sort of issues that you might face. So in this presentation, we don't have a whole lot of time, so I'm going to go over just the three first ones. So user needs, defining success, data collection and evaluation, and explainability and trust. So let's get started. Any questions so far in the presentation before I get started on the first section? I'm looking at the comments section right now, so if you do have a question, feel free. Okay, seems like no one has any questions. Then I will get started. So Cyan, I'm gonna need to communicate with you on this one, because we're gonna go through your project as an example for this for these three guides. Okay.
Okay, sure.
Cool with you?
Sure.
Great. So let's identify. The first thing you do when you're trying to understand the user needs and you're trying to define success is you need to identify if AI adds unique value. So even if AI or machine learning doesn't provide any unique value in this situation, there's no reason why you should use it. AI systems are complicated. They're very expensive to develop, and oftentimes they can fail in ways that you don't expect. So there's a lot of upkeep costs. If your AI system is not providing a substantial unique value, then this is probably a situation where you should ignore it or not even get into this project. Cyan, let's talk a little bit in the context of your shoplifting and emotion detection project. Mm-hmm. Is there a user need associated with a pattern of behavior for your project?
Maybe safety is one, because there's always the manager has to go over look at the CCTV again and again. So maybe that is one user need which should be satisfied, that just not put everything on the manager and let the AI do the thing?
That's a very good point. So there is the pattern of behavior, which in this case, I guess, would be there are people who steal stuff from stores in the world, right? And the owners of these stores want to reduce the loss profits and the lost revenue from items being stolen in their store, but it costs a lot of money and time in order to watch the cameras and double check. And even if you're watching it, you might not necessarily catch the people stealing. So yes, it does sound like the project meets this requirement. So we talked a little bit about success when you mentioned as well. Success is basically, as I understand it from your explanation just now, success is that the manager does not have to watch the CCTV cameras at all and will still get the protection from shoplifting. Is that correct?
Yeah, that is.
Great. So given that scope, do you think a non-AI solution would work?
I think it won't be able to, classify that who is doing what because it won't be smart enough.
Okay, well, the question is, could a non-AI solution work in this case?
Yeah, and I don't think the non-AI solution could work because you would need someone to decide whether what action is being done, like if he's stealing or not.
Okay, yeah. Very good. So once you figure out the scope of the need and you figure out whether AI is useful in this situation, Cyan, I think that is useful. Then you have to decide which AI is better. So maybe give us an example. Do you think completely automating the task or augmenting the task is what's needed for your AI solution? For those who don't know, automation is where the user won't do anything at all, and augmentation is where the system is helping the user make decisions. So Cyan, for your example, what do you think is more appropriate?
I think automation in this case would be more appropriate because if you have to go ahead and turn things on and off or like use a manual control for things because the manager can't always be there in the store. Maybe he has some work, he's out or something, and he forgot to turn the model on or anything like that. So in those cases, we would still need to monitor the camera. So I think an automation would be better.
Yeah. In this situation, I think your intuition is pretty correct. And we'll go into more detail about augmentation and automation in a later slide. So we'll get back to it. But in this situation, I think you might be right. So we want to always ask the question, can we use, we don't want to ask the question, can we use AI to do this? That's sort of the how question. And if we start with this, then we'll never really take into account all of these important questions. And this is the kind of questions you want to ask yourself and the conversations you want to have in order for you to go forward. What you want to ask is how might we solve this? Or can AI solve this problem in a unique way? So if we shift the questions we ask, then the outcomes dramatically change and potentially get much better. So usually I would talk about how a use case in the gaming company, but we're just going to stick to the shoplifting use case for now. Okay, so we ended up going through this section a little bit already with Cyan, but remember the need was that we wanted to keep the shoplifter. We wanted to stop shoplifting or minimize shoplifting without increasing the workload of the store manager. Okay, great. So let's talk a little bit about defining success. So, Cyan, have you managed to decide what metrics you're going to measure the accuracy of your system on?
For the emotion detection one, we have like the classifiers of happy, sad, and all that typical classifiers. So like when if the average is more than 60, then we consider the store as being happy in overall. Like the store has a happy rating overall, or else if it's less than 60, then people are not that happy. You need to change something. So that is for the emotion classification.
For the process of this, let's focus on the shoplifting, just because I think that's the more concrete project that we can talk about. The emotion detection has its uses and has its interesting parts to it, but it's maybe a little bit harder to talk about in this context. So let's keep with the shoplifting.
Okay.
And
so for the shoplifting, we do have the pose motion though, which like we are training it all with people who have shoplifted videos of that, and like if they see a similar kind of action, then it classifies it as shoplifting. But I know that's not the optimum way of doing it, but like we are still working on it.
Okay, so that's good though. Let's talk about a little bit about the effects of your AI system for the owners and the people who use the store. So obviously, in this case, your system either detects shoplifting or it doesn't detect shoplifting. And the person that's in the camera feed is either shoplifting or not shoplifting. So this green, you can sort of ignore the letters, the words inside of it, and we can just talk about it in this context. But the green is what actually happens. So in this case, we'll play player leaves. Is players we'll say that the person's not shoplifting, and this is the person is shoplifting, and this is the person not shoplifting, and the AI can either predict correctly or incorrectly. Now, in order to understand the success or the knock-on, this is a confusion matrix. Good call, GM. In order to understand the effects of this long term, we have to know what is good and what is bad with the AI predictions when they get it wrong or right. So in this case, I would say that if the AI system predicts that someone is shoplifting, but they're not actually shoplifting, that I don't see has it could have some negative effects. Actually, the shoplifter might accuse people who are innocent of shoplifting, and that if they are innocent and the shopkeeper accuses of them of shoplifting, they might never come back to the store, right?
Yeah, true.
If the system, if the person shoplifts, but the system does not detect that they're shoplifting, that's also a pretty bad outcome, because the manager is putting before they got the system, they would at least watch, right? They would be mindful of what's going on. They would be mindful of what's going on in their store. But when they get the system, they're putting their trust in the system. And if the system doesn't detect the shoplifter, then there's a potential for the shoplifter to actually lose more money than when they didn't have the system. So that's a really bad outcome. If the system doesn't detect any shoplifting and there is no shoplifting, that's a good outcome, right? That's exactly what you expect. And the same thing with shoplifters and the system detecting shoplifting. That's a good outcome. But the two negatives, the false positive and the false negative, actually have pretty bad outcomes. Cyan, could you give us could you try to make it clear about why the false positive and the false negative would be very bad for this potential business that you're trying to build?
Yeah, could you repeat the question? My network just cut off a bit.
Sure. So we talked a little bit about false positives and false negatives. So false
Mm-hmm.
positive, the shopkeeper thinks someone's shoplifting, but they're not, and they accuse. So that's a pretty negative outcome. And the
Mm-hmm.
same thing for false negative, the shopkeeper isn't notified, and therefore uh, and isn't even trying to look for shoplifting. So they end up losing more money in the
Yeah.
long term.
Mm-hmm.
Uh, are those correct categorizations? Like, did I categorize that correct? What are the
Yeah.
effects
Yeah.
of these?
Yeah, so like if someone tries to shoplift, and with like, because we have trained it only with the videos, and if someone like generally doesn't want to shoplift but he's trying the same kind of motion which it is trained on, then that will classify it as a person who is shoplifting, which is actually incorrect. So that is false negative, I believe. And then another person who's actually shoplifting, but not in the same way like we trained it, he's doing it in a different way, so it doesn't categorize it. So yeah, you are absolutely correct.
So is this? I mean, when you come into this, you could either say when you do the study of this, you could either say, hey, these are very serious effects, or they're not very serious effects. And they're going to change the way that you priced the system. They're going to change the way, this is going to change the way that you sell the system to shopkeepers. And it even might change the way you build the system when you take these things into account. If you don't take these things into account, the problems will still be there. It's just you wouldn't have thought about it, and you wouldn't have taken the necessary steps in order to fix the situation. I find in my experience, many people don't actually think about this. What are the effects of your system being wrong? And then actively measure the system to double check that everything is good. So of the false positives and false negatives, Cyan, what do you think for your system? What do you think would be the what do you think would be the correct thing to optimize for? Do you want to optimize for reducing the amount of false negatives, or do you want to optimize for reducing the number of false positives? Because you can't do both. You can only pick one. So what do you think is in your situation with the shoplifting, the more correct thing to do, given your knowledge of and understanding of the user needs in this situation?
So I think if like in my project, I would love to optimize the false positives instead of the false negative, because incorrectly categorizing people as shoplifting is still bearable, and like, but if you like don't do anything about the shoplifting, then ultimately there's no point of the project. So I think I'll be optimizing the false positive according to
That's
me.
okay. Yeah, and there's not going to be any to be honest with all of you guys here. There's not going to be any right answer. So Cyan is obviously the expert in this project and in the user needs that he's trying to solve. Um, but this is something you all have to ask yourselves when you're building AI products. And if you don't, you're in for a bad time. So given the scope of the work, let's just go, we'll skip a little bit here. Let's talk a little bit about the differences between automation and augmentation, like we talked about earlier. So when you do automation, you're automating things that people don't know how to do or that are difficult. You're maybe automating something that isn't something that people can do, something very dangerous, perhaps waste disposal or something of this nature, or you're going to automate a task that is very boring, repetitive, or dangerous. For augmentation, you would generally augment something, and augmentation is when the AI system and the person work together in order to create a successful outcome, whereas automation is just the system is running. So in augmentation, you would generally do that when people enjoy or feel responsible for a task. Where there's high stakes situations, let's say in the case of medical AI that's doing screening. So you wouldn't necessarily want to do this all automated. You would want to have a person in the loop. or if there's very complicated personal preferences. So in this case, we have Cyan is talking about building an automated system. But could anyone think of a system that is more augmented, a system that's has augmentation at its core and isn't purely automation? So GM is saying recommender systems. Well, the recommender system, you're right. Recommender systems are in like a couple. It's like a coupled system between the user and the automated system. But I would say recommendation is more on the automation side, because yeah, the user interacts with the system and the system changes over time, but it's not necessarily a system in which a human and a automated system are working together in order to accomplish a task, unless the task you care about is, getting you to stay on Facebook longer, which is not something I really consider. I guess augmentation of the easiest example I can come up with. Because I'm not seeing a whole lot of interaction in the comment section, would be the doctor situation, where you have a radiologist who is going through an X-ray image, and the doctor the AI system is recommending places that it thinks are of issue, and then the doctor or the radiologist is looking at those areas and using their extensive knowledge, then picking yes or no to a specific diagnosis based on the AI system. That would be a more augmented system. But there are lots of examples. I suggest you guys take some time and research this at another time. So in this section, the user needs, we identified if the patterns in people's behavior that we're trying to augment or automate. We defined success in a way that's people-centered. We determined if AI was actually needed for the problem, and we decided what type of AI was correct in this case. So any questions on this section? User needs and defining success.
Hey, I just wanted to know that, because this one we have thought of building it in an automated way, but later on, can we shift the requirements and make it augmented? Is that something you do?
Yeah, I think to be honest, Cyan, I think in your case, the augmented solution might be better because you can think of it more as a tool for you to help a single person watch more cameras, or to cover more ground, or to do it in less time than they would normally be able to do. And that still keeps the person in the loop. So at the end of the day, the responsibility is not on the AI system to catch all the robbers, but the responsibility lies on the person watching the system. Mm-hmm. And if it's augmented, the system can learn over time based on the user input. So the system would say, hey, I think 80% chance there might be a shoplifter here. And then the person confirms or rejects that hypothesis. And that becomes a training data case that you can go forward, you can go and train your system against later on. So your system will actually improve over time.
Okay, yeah, so that's definitely a better choice, yes. Mm-hmm.
Any other questions regarding this section? I'm watching the comment section, and I'll wait for 10 seconds to see if anyone posts. All right, well, there doesn't seem to be too many questions, so I'm going to move forward. But if you do have a question, continue to write, and I'll stop and answer it once if you post it. And it looks like we're running a little bit short on time. This is a very dense topic. I wish I could talk to you guys over the course of a 10-hour course like I normally do this kind of thing for. It usually takes 10 hours. So we're going to go over one more section. And then I'm going to skip the last section and go directly to the part where I'll give you the link for the actual guidebook so you can go over it at your own time. So once you have the user needs and you understand success and you know what kind of system you're building, whether it's automated or augmented, now it's time to translate the user needs into data requirements. I see a lot of people and a lot of machine learning engineers, they start with the data and then they build a system around that data. And that's the backwards way of doing it. It's the easy way of doing it because there's so many data sets available. But if you really care about the user needs and solving them in the most efficient and valuable way possible, you're going to want to start with the user needs and then pick your data based on the user needs, not the other way around. So let's talk a little bit more about the user needs and translating user needs into data needs. So the first thing you want to do is sort of align the people's needs with the possible AI outputs. You're going to have to ask yourself, are the AI outputs that you're trying to get map onto an attainable training data set? Getting training data is often the most time-consuming and expensive part of doing the ML system. So you want to see that the outputs that you're trying to get actually will lend themselves to be allow you to get a training data set. You're going to have to consider where and how to source the amount of data that you need and the diversity of the data you need. Machine learning systems are stupid. There's no AI. There's no AI in AI. It's just pattern matching on data. So if your data set is poor quality, your machine learning system is going to be poor quality. And garbage in is always garbage out. I love that saying, and I think it's something that you should put on your wall if you're trying to be an ML engineer. Garbage data, garbage in, garbage out. And then you're going to want to consider how to tune your AI model over time. So let's talk a little bit about how you might align user needs to AI outputs. So in this case, I'm going to go back to the go back to the original example, not the shoplifting example, but the example from the gaming company that I'm the AI lead for. In this example, we use AI to pick the best products in order to maximize the user staying inside the game. So the user need is they want incentives to stay. And the output is basically, is the player likely to leave? If so, then what is the recommended incentive? Those are the AI outputs. So in order to allow for those AI outputs, the data we're going to need is the user behavior in the game. We're going to see how they spend money in the game, and we're going to see what are their item preferences. So that's the data we need in order to generate this AI output. Once you've done this exercise, you've made these 3 tables, and then it's relatively easy to map it to a structured data set. So I'm pretty sure a lot of you guys are very familiar with this particular setup. It's just as a standard table, and you have columns and you have rows, and the rows are it's just a standard structured data set. Data sets can come in a bunch of different varieties, like image data sets and things like that. So Cyan has just posted a question. He said, should you start with math when starting out with AI, or directly go to testing and training with Python or any language? My opinion is that you don't necessarily need math in order to use the tools that are available in order to train the AI systems. Like, you don't need to be able to do derivatives in order to make this work for you. You really don't. You can build product without understanding the high-level math. An understanding of math will help you, I think, understand the optimization process. And what's more important probably is that you have an intuitive understanding of loss functions and their effect on training the AI system. If you're going to be training your own AI systems, instead of using some APIs from Azure or AWS or Google Cloud. So you got to really decide what your goal is from this. Do you want to be an AI engineer where you're developing new AI systems? Or do you want to be a software engineer that has AI skills? Because depending on what you want to be, the answer to your question is going to be different. If you want to be a researcher, you want to push the boundaries, definitely learn some of the math. If not, then I think it's something that you can skip.
Okay, so think of it like I do not want to be like a researcher level of an AI, AI researcher, but just if I have an AI project and like people in the interview section, like when the HRs, so can they go deep into the math for something like that? Or will they just ask about the optimizers and all that?
So the optimizers are all math-based, right? So when you do the optimizing, you have to pick a loss function, and the loss function, based on the mathematics behind that loss function, they have different benefits and drawbacks. Like mean squared error is really good at helping stop your system from generating an output that is very wrong, because the error is squared the larger the error is. But that's not necessarily the best loss function for forecasting. Like if you're doing a regression, that's not necessarily the best option you have. And so when it comes to, like, if you're designing a system, you're not like a researcher, but you're making a new system, you do have to have an understanding of the different loss functions and the mathematical significance behind their output, because different loss functions have different outputs and different positive strengths and weaknesses for sure. So if you're going to be building your own system, you should definitely understand the math and understand what's going on there. If you're using APIs, don't worry about it.
Okay, got it.
Okay, so let's get back to the data set really quick. So you can see we have each row is an example, and then labels. I think this is pretty standard stuff, so we're not going to go through it because we're running a little bit short on time. But I do want to talk very quickly about sourcing your data because it's of the utmost importance. If you're a large company or you have a pre-existing product, this is not going to be such a challenge for you because you generally have a lot of data, and if you're solving your user problems, it's very likely that you have the data you have the data that matches the requirements of the system. So for transformers, we had this data. It wasn't hard to get at all. But for smaller teams or individual researchers or developers, this will take a lot of work. And I can see why individual developers, smaller teams, they tend to focus on finding data and then building systems on top of the data they can find, just because it's so expensive to generate this data. But I hope you can, if you're going about this and trying to source your data, that you'll ask yourself these important questions. Is there a publicly available data set for your system? Cyan, is there, for your shoplifting, is there something publicly available?
Yeah, we are using the FER dataset for emotion, and for shoplifting, we have like a dataset already from Kaggle.
Okay, so it looks like, yeah, you definitely asked yourself the question. There is publicly available data set. Does your data set contain enough example diversity? So Cyan, if you develop this system, where in
No,
the world
no, that
is
is
the
not
system?
something we have though, but we sometimes need to, hello?
Yeah.
Hello, I think I'm back. Yeah, so that is not something we do have. Like there's not enough diversity. There is though, but for sometimes we have to record our own faces and like own videos.
Okay. So that's a good point. Does your data set contain enough examples? You have to think about where your product is actually being used. So I guess in Cyan's case, your product is going to be used in what kind of store? Actually, is it a small store? Is it a big store?
It's mostly supermarkets.
Supermarkets? In what part of the world?
Mm, that we are only targeting India for now, but yeah, can
Okay,
grow.
that's fine. So the thing is, an Indian supermarket looks very different than a Chinese supermarket, and that looks very different than an American supermarket. And even the way people act inside of these stores is very different between different geographical regions. So I'm not sure where the Kaggle data set is from, but I'm going to guess it's not from India. And so I
Mm-hmm.
already see a major issue that you guys are going to face is that you guys don't actually have any data for the market that you're trying to solve. And so your system will perform very, very poorly when it first gets started inside of the Indian supermarket.
Yeah, that's an issue.
So you gotta put yourself in the shoes of the customer and really understand what's their local context and how can I get data that's gonna help my system perform well in that context and not in the context that my publicly available data set is it's from. So if I was you, Cyan, I would instead of focusing on building the system, I would get in contact with as many Indian supermarket owners as I can, and try to get them to help you source this data, perhaps for free service. Like when you finish developing, they'll get like a free or reduced cost service, or some other kind of model, because your system is not going to work as it currently is, just because of the way that you're sourcing your data. And this is why sourcing your data is such an important task, and it's why a lot of people, they start building before they really understand this asset, and it ends up costing them a lot of time and effort later on.
Mm-hmm.
The
But
last
the
bit,
the data is not, the supermarkets won't give you the data for free, or like it's not like, they have privacy issues, I believe.
yeah, so there you go. That's the second part of this. Is your data set free of privacy and fairness issues? Um, this is important for a lot of people. Like Syed just mentioned, the shop owners are worried about privacy issues. So this is something that's not an easy solution. Now, I'm not sure Cyan's intentions with his product. I don't know whether it's a real, if he's trying to really make money from it, or if he's thinking of it more as an interesting project to work on. But if he was thinking about making money on this system, he would really have to think about these privacy issues and fairness issues, because as more and more countries develop regulations around this, there are going to be issues that you're going to have to face when you collect data. Just so really quick, I want to emphasize this super importantly. Sourcing the data set is very hard, and it's not. Yeah. Each one of the questions can be its own talk, its own 2-hour session to go over. You can't. I don't want you to think that it's impossible, though. It's definitely possible, and this is when it's really important to ask for help. So if you do need any help, if you're working on a project, you do need help understanding the data set issue, like I just worked with Cyan on, then please get in contact with me, and I'll try to help fix this issue, because solving this issue, if I can help you solve this issue, I think that solves 80% of the problems that you'll have. Finally, let's talk a little bit about tuning. And many people they develop the AI system, they put it into production, and then they're done. They leave it alone. That's sort of the opposite of what you want to do. And so right when you're doing the model tuning, I think it's very important for you, right when you're sourcing the data, you're doing the data set, it's very important for you before you even start developing an AI system is to understand how you're gonna measure the system after you put it into production. And then basically set up ways of you detecting if there's going to be any issues. So in this, you might think of this as, to put it in the context of Cyan's shoplifting example, the metric is probably accuracy. So like the system gives you a prediction of shoplifting or not, and you're doing that specifically. So if accuracy for shoplifting goes, let's say below, if the accuracy measured is below a certain threshold percentage, for this example, we'll say 70, but Cyan, as the business leader on this, you would be responsible for picking the one that would work for you. Then you'll want to do specific actions. So this is just setting up a very easy feedback loop. If you don't set this up, you might put the system to production, and then 5 months down the line realize that the system no longer really works anymore because of user complaints and things like this. And it would have been much easier to catch that problem yourself, let's say 1 month into deployment, if you had this sort of model tuning catch. So if you had set up this specific catch, then you would have maybe found the issue much sooner, and you would have been able to fix it before the customers really noticed. So this is a pretty often ignored aspect of machine learning systems, but their accuracy and their performance does change over time, and you're gonna have to set up reminders to check and double check these kind of things.
Mm-hmm.
So really, go ahead.
Yeah, I was agreeing with you.
Okay. So in this section, we aligned the needs with the AI outputs. We mapped it into a usable data set. We sourced the data set properly and inspected it for a diversity and how well it matches with our local context. And then we set up hooks that would allow us to fix any issues that might come up after deployment. So usually I would go into the explaining your AI system. We're gonna go past this right now, and we're going to go right into. So to give you an example of, so I started doing this approach for the Transformers app. And our system performed very well, and we reduced the churn rate of users by 30%. So we got significant value from this AI system, and it's because we followed this particular format very well. So before we even got to coding or sourcing the data set, we asked ourselves all of these questions and made sure that we understood what was going on. So. Here, I'm going to send this link, copy this link to the chat. This is a really great, what's going on here? People plus AI research is a great tool set, and it has all of these interesting, it goes into details about all of these interesting things. I highly suggest you take the chance to read through it and learn from this. Okay. I'm gonna go back. Let me go back to. Okay, we'll go back down. So just want to thank you, and I guess I'll take questions now. Okay, so I'm going to answer them in order. Go ahead and just post your questions, and I'll try to answer them in order. But the first question is from Cyan. What would be your second most favorite love domain if it wasn't AI? I think this is a really easy one. I would love to be an astronaut. More specifically, I would love to be an asteroid miner. I love space. I love technology. If I wasn't doing this, I would be working at NASA trying to mine asteroids or something like this.
Wow. Have you seen Interstellar?
What's that?
Have you seen Interstellar or like any other movie? Gravity.
Yeah, I love sci-fi movies. I love sci-fi books. As Isaac Asimov, the Foundation series, the Culture series by I.N.M. Banks. I'm a big sci-fi nerd, so
It's
I
also
definitely
nice.
love sci-fi. Okay, so we have another question. How will the current pandemic affect innovation in AI in the field of healthcare? Well, I've seen a lot of people doing like classifiers for classifiers for classifying corona virus in X-rays, chest X-rays. And again, this is an issue. These systems that people work on, it's clear they didn't think of any of these. They didn't go through this guidebook. They didn't consider the user needs, because the bottleneck in this is not identifying COVID in patients through chest X-rays. Actually, it's pretty clear to see that there's something wrong with the patient by the time they need a chest X-ray. They usually are very out of breath and they can't think. So it highlights the fact that people aren't thinking about user needs. The real bottleneck is PPE, getting PPE, or cleaning and disinfecting medical devices. It's not classifying X-rays, but lots of news outlets talk about it. So I'm not quite sure what's going on there. The coronavirus is not going to be solved with AI. The modeling potentially can be improved with AI, the pandemic modeling, but forecasting is a very difficult science, and I don't think generally you want to keep that. In this field, it's better to have expertise than it is just to apply AI to this. So I don't know if any of the examples of AI helping this pandemic have been useful at all, to be honest with you. But I'm always open to being proved wrong. Next question. What would be the future AI prospects? Could you help me understand this question a little bit more? Do you have, are you asking more generally, or is there a specific subfield that you're interested in? So I'll let you expand. Okay, in general. Okay. I think AI, people like to say that AI is going to replace the jobs and things like that. And there's definitely jobs that are going to be replaced by AI. But in general, I see AI, the future AI prospects to be very good, and also pretty beneficial to society as a whole. Like, I think the majority of solutions are not going to be completely automated. I think they're going to be augmented. So we're going to add AI to the things we're already doing and to make them better. We're not going to use AI to automate things willy-nilly because the real AI assumes the data set is always limited. There's never enough data, and so there's always going to be edge cases or cases where the system fails, and there's going to need to be a backup. Otherwise, you might catastrophically fail in whatever product you're offering. But in general, AI is going to continue to be a huge field. I've seen some people talk about where sort of like the next AI winter is coming, and this and that, and even if we stopped all the progress in AI completely today, if we had no more progress, I still think that the amount of use cases that AI, as it is now, could be applied to is huge. So we have at least 10 years of very hard work across an entire industry in order to use up all of the innovation that has been developed in the last 5 years. So I don't think you have to worry. If you want to get into AI, don't listen to all these AI winter people. Sure, the funding might dry up for bad AI products just because the hype is gone. when the hype is gone, then it's harder to get money for bad AI products. But there's so many good AI products that you could build right now that add a lot of value. You just have to talk to the users and understand their problems and help them solve that. So in general, I'm very excited for AI prospects in the next 10 years, even if all progress stops. There's going to be a lot to do. Yeah, time and time again. GM mentions that drug modeling for finding vaccines could be a good AI venture. Yes, I agree. It's a very amazing use case that will help a lot of people. I don't know. You generally have to be a large medical company in order to really see the value in that. Yeah. Okay. Well, is that all the questions? I don't see any more questions.
Hello.
What's that? Okay. Well,
yes,
I
okay,
think go ahead.
Someone is trying to speak.
Yeah. So.
Yeah, Rajta. Yeah, go ahead.
Yeah. So after hearing your interest in space, I felt like I should share this project I'm working on. So, like, I am working on an open source project. It's called Polaris. In that, like, we are designing a model to predict the trajectory of a satellite by using the telemetry data we are getting through, like, from the satellites. So, we are predicting using time series forecasting. So, I felt like sharing it with you. And like, the space and all also fascinates me a lot. Like, before opting for computer science major, I was like planning to go for aerospace engineering, but later I fell in love with computer
science. I can't really hear what you're saying. I'm really sorry, but you're breaking up too heavily. Could you type out the question?
He was actually talking about a project he's making on, like, you mentioned that you are a sci-fi fan, so he's making a model which can predict the satellite, like take data from satellite and predict the trajectory of rockets. I believe that's what he said.
Okay, that's pretty interesting. I'd love to learn more. You can. I did send a link to the group chat because we are coming towards the end at this. To my website, to the sort of EducateAI page. You can ask me questions here directly or share your AI models, and I'll be more than happy to interact and help you out. I'd love it if you followed the page and interacted a little bit more with the EducateAI stuff, and I'm sure we could do more going forward with the Microsoft Student Partner Group as well.
Yep, we would love to, and we would make sure that people, get in, like, engage with EducateAI. Like, it's a really nice initiative, and like we'll try our best. And yeah, I think since there are no more questions, I would request if there are any, you please go ahead and ask Chris, or like he mentioned in the chat, you have the ID, you have the address, so you can just go ahead and ask it there. So thank you so much, Chris, for this amazing session, and it was really amazing having you here and like discussing my project or people's project and like taking a really deeper look into that. So it was really great.
Yeah, I hope if there's anything you guys learn, it's just that you go to this website, the People Plus AI Guidebook, and you go through it before you start any project. I think it's going to help you answer a lot of questions and get your project off to a great start. Sure,
we would love to see, like that is my first project, which I just told you. So yeah, we really started off with something big, but yeah, thank you for like clearing a lot of things out. I didn't know about the data part though. Now I look into it. Thank you.
Great. All right, thank you guys. It was wonderful to speak to you. You all have a wonderful night, and I look forward to hearing from you guys in the future.
So we wish the same for you. Have a great day and all the best for your call. And thank you for joining in today. Thank you.
Right. Bye-bye.
Bye-bye. Okay. I